Welcome back, Splunk enthusiasts. This video is brought to you by Lame Creations, log analysis made easy, where we help you master the tools and techniques to become a Splunk pro. Welcome to another video by Lame Creations, log analysis made easy. In this video, we're going to discuss scalability considerations. Your environment as it stands currently is probably only going to get bigger. General rule, I don't see people continue to shrink down how much they use Splunk. They just continue to increase. So this video will discuss what we need to know, what we need to be considering as we go from a small Splunk environment to a larger Splunk environment. So the big two things we're going to talk about are the indexers and the search heads, and some things to consider. These are all rules of thumb. I give them out there primarily for those who are doing the capacity planning. There's certifications for planning an environment. You're going to be asked those kind of questions, and there is no perfect answer. The problem is you're going to be asked questions on a test, so we're going to cover more or less what will get you through the test. As a general rule on indexers, when a search is performed, you think about this, I'm going to say on the indexer, but I'm talking about searches. Well, your search head will query your indexer. So an indexer is involved in searches. And typically we say a search consumes 1 core of CPU and 1 gig of RAM. Again, that's that general rule of thumb. It really doesn't always work that way. It's never that clean, but it's really good for when you're being asked questions in a general. If you have 16 cores, how many concurrent searches can you run? Well, you've got to support the operating system, you got to support Splunk, and so you definitely cannot run more than 16 concurrent searches. It's going to be less than that. Typically, you think 1 core for your OS, maybe 2 cores, and then Splunk needs a core, so you're going to have maybe 13 at best concurrent searches, and then you got to consider your RAM, all that. Indexing volume. This is going to be very based off your system spec. This number has changed so much over the past, and I can speak from personal experience. This 400 gigabyte level, that's okay. It's a good rule of thumb. Sure, let's go with that. But again, so much of how much you can index is going to be based off your network pipe. It's going to be based off what you're writing to. We have an environment I'm working, NVMEs. We get significantly larger than 400 gigabytes per day on an indexer. We can get up to 1 to 2 terabytes. But you know what? I would bet my system at home with its little spinny disks, no, I'm not even using solid state. We're just talking good old hard drives, standard ones. That 400 gigabytes per day may be about what I'm going to get. And so we just use the general rule of thumb, 400 gigabytes per day. So if you're ingesting more than 400 gigabytes per day, you're going to have some problems. Data resiliency. What happens if the indexer crashes? What if a disk corrupts? How do you get that data? Do you have a RAID solution? What are you going to do to make sure that you don't lose data from your system? Jump over to search heads. Same concept. Every search that's running, 1 core, 1 gigabyte of RAM. Other things to consider, you might be using data acceleration, T-stats. When you do that, that's going to eat up more of your system resources, data resiliency. I put that here. Generally, I don't think of it as that important, but all of your apps on there, if your disk was to crash, can you afford to lose those? Another place that you might find things that are important is KV stores, CSV lookups. If those are sitting on your system and they're highly important, what happens if that data corrupts? So data resiliency is something we want to think about from the search head perspective as well. While not nearly as important, there is places where the data is important that if you lose it, do you have it backed up? So the primary method that you'll hear in Splunk is clustering. Technically, you can do an indexer with 2 indexes. Sorry. And you can use 2 indexers and you basically completely duplicate indexer 1 to indexer 2. So if the data corrupts from a data resiliency perspective, that will work. I'm not going to specifically mention that as this case. That is an option to do, and then you get none of the other resiliency capacity stuff. So we're going to talk about primarily the clustering as a indexing cluster. And in order to have a cluster, you must have 3 or more systems. Again, someone's going to say, well, you can technically cluster with 2. That is true. Again, a lot of this is to help you, one, get what's best practice, two, help you pass your certifications. And so 2 is not the right answer. It's 3 or more. And so basically you build indexer 1, indexer 2, indexer 3, and you have what's called a manager node. For historical purposes, it was called a master node, but now they call it manager node, so that's the term we'll use. The manager node itself is in charge of making sure these systems load balance. It will make sure that all of your stuff is backed up, striped. In your manager node, you will set up search resiliency and storage resiliency, how many copies, how many disks can crash before you lose your ability to search, how many disks can crash before you lose your actual data. All of that is controlled by the manager node, and then it takes care of that so that many copies are available. That's clustering in its simplest form. Concept here. Now, when searches are done, if it's you can spread out the resources so you have more more CPU, more RAM across multiple systems. That'll help with that. You have more storage. You have in case disk failures, things like that. So that's how the manager node works. Jumping over to search head, it's slightly different, but it really does follow the same format. You must have 3 or more search heads. So I got search head 1, search head 2, search head 3. Technically, we're going to say the deployer and the manager node follow a similar concept, but it's not truly the case. So a deployer is not to be confused with a deployment server. They are different. A deployer is solely focused on pushing things out to search head clusters. A deployment server could push to an individual search head, to universal forwarders, to an individual indexer, etc. But that is not what a deployer is for, which I did forget to mention that a manager node will also control the deployment of applications, of apps, to your indexers. The deployer will control the deployment of apps to your search head cluster. And a deployment server is for individual systems. It is not meant for clustering. So it's unfortunately the names are very similar, but you got deployer and deployment server. Anyway, so with the deployer, you've got this capability here. We're going to use another term. The term is called the captain. The captain is randomly more or less picked from these 3 search heads, and it is set as the captain, and it makes the determination where my resources are free. The manager node controls the resources here. The captain controls the search head cluster, and the captain will say, I've got some free resources, so I'll handle that search. You know what, I'm busy, you run that. Oh, we got a scheduled save search. You know what, search head 2, you're kind of free right now. Why don't you run that? And so that's what a captain does. And the easiest way to think of it is the deployer is going to have some apps. Maybe in that app you have scheduled searches that run. It's going to make sure that scheduled search is on all 3 of those systems. But the captain will make sure that it only runs once. Yes, the app is here, here, and here, but the search head, only one search head will run the save search, and that's controlled by the captain. It's going to look at the resource and say, you know what, you got the most free resources right now. You run that save search. So in a search head cluster, it's slightly more complicated. But again, you make a user logs in, they log into say search head 1, they modify the KV store. That will then propagate to all 3 systems. You change a dashboard, it will propagate those local changes to all the search head. So it provides resiliency as well. That is the big thing that I would pay attention to, is with clustering, you have an indexer cluster managed by a manager node. For search heads, you have a deployer that manages the deployment of apps to a search head cluster, and a captain that manages how the searches are distributed among the search heads. Thanks for tuning in to Lame Creations, log analysis made easy. If you found today's video helpful, don't forget to like and subscribe so you never miss out on the latest tips, tools, and tutorials to boost your log analysis skills. Want to take it a step further? Become a member to support the channel and gain exclusive early access to videos and exclusive focused training. Join us on Discord where we dive even deeper, share insights, and tackle questions together. Until next time, from Lame Creations, where we help you go from being a lame analyst to a Splunk ninja.